So if we produce quark at the LHC, we can't just directly measure them. What we measure is a lot of particles which come into the same direction, which we call a jet. And if we want to identify the flavor of the jet, which means which kind of quark it actually originates from, we use machine learning algorithms to do that. And you can, for example, see here, this could be a B jet because there is actually some displacement here, which we can reconstruct from the detector. And for example, if we have a jet from a lighter quark, we don't have that. But if we want to use algorithms like that, we need to take care that performance is actually the same on simulation and the measured data to do precision measurements, and that's why we calibrate these algorithms.
Hi, what I am presenting here is the new CMS search for long-lived particles decaying to a pair of muons in the CMS detector. Long-lived particles are particles that may have a considerable lifetime and decay displaced in our detector. In this search, we perform it with 2022 data from CMS, and this analysis is an extension from the equivalent Run 2 analysis. The key thing of this analysis is that with 1/3 of the data collected, we were able to improve our results from Run 2, thanks mainly to the improved triggers that are new for Run 3. These triggers focus mainly on lowering the PT thresholds of the muons that we acquire, and also removing the beam spot constraint, which is very good for triggering with displaced objects like displaced muons.
So hey everyone, today we're talking about triggering on long-lived particles. There are a bunch of theories that predict particles that can actually move several centimeters before they decay into smaller particles. And currently CMS isn't really equipped to look for these types of particles at the level 1, particularly using track information, which is the measurement of the trajectory the particle took in the detector. What I'm doing today is taking this track information, which is the momentum and direction of each particle, and seeing if we can reconstruct where these long-lived particles decayed and then trigger on those so that we can save that information for a later analysis of the data in the detector. So using some machine learning, it turns out that you can actually distinguish these long-lived particles from just background that you get in the detector.